Alright, problem we have says a man-made lake initially contains 200 gallons of water with 50 pounds of the chemical dissolved into it. Solution containing 3 pounds per gallon of the chemical runs into the lake at a rate of 4 gallons per minute, and the well mix solution runs out of the lake at a rate of 4 gallons per minute. Now, to find the maximum amount of chemical ever in the lake, we set up the differential equation, and basic model would be the rate of change equal to rate in minus the rate out. Setting this up, on the left-hand side, we use dy over dt, the change of y, or the change in time. And for y, it would be the amount of the chemical. So we'll use that in this equation. The rate in is given to us as 3 pounds per gallon, and we also have 4 gallons per minute. So we're looking for the weight and time, which the units do cancel out, gives us pounds per minute. And now the rate out, we're going to be using y, the amount of chemical, and 200 gallons is the initial amount they give us. Multiply that by, it tells us it leaves at 4 gallons per minute. So multiplying these together gives us the result. Dy dt is 12 pounds per minute minus y, or 50 pounds per minute. So we're given also at t equals 0, y would be 50. That's our initial condition. So to solve it, we need to rearrange the variables and set it up so that y prime, or dy dt, is by itself, and the other variables on the left side. So we have 1 over dy, that's all equal to 12. And of course the initial y of 0 is equal to 50. Now we take the integrating factor, which is the coefficient attached to y, plugged into e raised to the integral of that number, 1 over 50 dt. And solving that gives us e to the t over 50. Now, multiplying each term by the integrating factor will give us this on the left-hand side, e to the t over 50 times y, which is equal to the integral of 12 times e to the t over 50, right? To solve this, we can use u substitution, which would be u is t over 50, and finding du dt, dt will turn into 50 du. So take out the coefficients outside of the integral, and leaves us with 12 times 50 with the integral of e to the u, which, keep going, the integral of e to the u is itself. So solving, multiplying the numbers, and solving the integral, and plugging back in, gives us 600 times e to the t over 50 plus c. And now we need to isolate y, so divide every term by e to the t over 50, just giving us y equals 600 plus c times e to the negative t over 50. So now we do have the initial value. We can find c. So we know that y of 0 equals 50, which would be on the left-hand side. We can replace y, in this case, is equal to 600 times c times e to the power of 0, because we know t is 0. So e to the 0 give us just 1, and 1 times c, so that is just going to be 50 minus 600, or negative 550. Now, plug back in the constant, we can get the differential equation of y of t equals 600 minus 550 e to the negative t over 50. Okay, now for the max amount of the chemical. Taking the differential equation, we can use the limit as t approaches infinity. Just as time goes on, the lake gets diluted with the mixture. So we know that e raised to a very large negative number will approach 0. So this whole term will approach 0, and the limit turns into 600 pounds. So 600 pounds of the chemical will be the max in this case. All right.